We're now live. All right. Welcome to Algebra 2, Lesson 3-9. We are on Monday, October 19th, 2020. We just read Sugaku Girl, Chapter 5, well, part of Chapter 5. It looks like that. This was the first page that we started with. All right, so you can still use the manga if you need to. What is an equation? It holds true for what? Yeah, what?
For only some values of x.
For some values of x. Thank you. And identity holds true for someone aside from Wyatt? Someone that read the manga, which should be all of us. No? Okay, well, let's go back to the manga. Let's see where they talk about this. There it is. Equation holds true for only some values of the variables, and identity holds true for any value of the variables. And they don't say x because you could have the variable be anything. So we'll say down here, holds true for all values of the variables. And if you disliked reading the manga to learn the math, you can let me know. I have plans to try doing this in the future for your class and other classes too. It worked. Nice. All right, thank you. You'll have to teach me, yeah. Because I spent my entire...
Hold on.
Yeah, I'm very hungry and I cannot wait to eat my lunch later. All right, so that's the main thing to take away from the comic. And there are a bunch of other cool things, like what is the person behind the math really saying, and a bunch of really, I think, interesting things. But let's move on to today's lesson. A review from, I think we learned this back on Thursday? No, Wednesday, so a while back. That's right. A plus b quantity squared is what? How do I expand that? Remember rocking your child to sleep? Square the first, double the product, square the last. Who's got this for us? Charles.
That can be expanded into a plus 2ab plus b squared.
Tiny little mistake, see if you can find it. Yeah, there it is, a squared. Yeah, and then just make sure, again, that these two signs, this sign and this sign, match each other, and you're good. If this was a minus sign, it would be minus 2ab. Other than that, it's pretty much the same. All right, a plus b, a minus b. Are you answering the next one, Charles? Are you ready to go? Who else is ready to go? A plus b times a minus b, this conjugate pair multiplies out to what? Trying to remember what we forgot from the weekend. Two people know, Charles and Wyatt knows. Someone aside from Charles and Wyatt. A plus b times a minus b. I have a feeling that one of these is in the manga. I can't remember which one it was. Oh no. Okay, I'm waiting. You guys have to go look at your notes. Oh, it's at the very end. Look at your manga, very back. There it is. It's basically right there. They use X and Y instead of A and B. Look at your notes. Look at the manga. It's somewhere. Jade. There it is. A squared minus B squared. Thank you. All right. So this lesson and the homework is entirely based off of those two facts. Yes, they do slight little twists to them to make sure that they are or are not identities, because otherwise it'd be too easy. It'd be the same thing over and over again. But if you know those two things and you have them down really well, then the rest of this lesson shouldn't be too hard. All right, so every one of these is an equation. Why? Because it has an equal to sign. That means it's an equation. It might be an identity, which means it's true for all values. The way to verify that is to make the left-hand side and right-hand side look like the same number. All right, so if you just kind of look at A and eyeball it, if I do x plus 1 quantity squared minus x squared, ooh, it could be 1 because, right, it's going to be x squared, x squared, and you're going to get rid of x squared. It might be 1, but we won't know until we actually go through and check it. And let me check to make sure. All right, that is now there. So I'm looking at A right here, the left-hand side of this equation, which might be an identity. I need to expand this out. I need to expand x plus 1 quantity squared out. Who can do that for us? Same people over and over again. Okay, I'll let you guys participate twice, but then I'm going to have a longer cooling off period. Even better. Andres.
X squared plus 1.
X squared. So that's squaring the first, and then you're going to double the product, right?
Yeah, that's 1.
Well, what's the product of 1 times x?
Oh. Is it just x?
X, and then double the product. So double x. Double x.
2x.
2x. So x squared plus 2x. Then squared last.
Is the last one?
1.
Is it negative or minus x?
It's just 1, yeah. So again, my first is the x, my last is the 1. So when I square the first, x squared, double the product of x and 1 is 1x, and I double the product, so it's 2x, and then I square the last. 1 squared is 1. You guys all remember the way to rock your baby to sleep? It will put them to sleep. I swear, I just did this to Riley the other day too, and it still works. Square the first, double the product, square the last. So we expanded out the square, but we still need to write down the rest of the equation. We haven't written down minus x squared is equal to 1. I only rewrote x plus 1 quantity squared. So here I go. Minus x squared equals 1. Let's keep reducing and simplifying this left-hand side. I should just say simplify. Reduce refers to fractions. All right, so left-hand side. So one additional step that we can do. Why?
You can subtract x squared from x squared, which would cancel each other out. And your final would be 2x plus 1 is equal to 1, which is not true. Or it could be true, but I can give you an equation, not an identity, because it could only be true for one value of x.
Yeah, which value of x would it be?
0.
Yeah, exactly. Because you subtract 1 from both sides, you get 2x is equal to 0. Divide both sides by 2, x is equal to 0. This only works for one value of x, and that's when x is equal to 0. So go ahead in our notes and cross out A. It's not A. Only when both sides are equal to each other, the left-hand side and right-hand side are the same, is it called an identity. Otherwise, it's just an equation. Let's try B. Again, I'm going to multiply this out. And this is, I put this on here because it's one of the problems that does not really depend on these two formulas. This is just kind of foiling it out. So FOIL stands for first, outer, inner, last. So first, y times y. Jade. Not quite. Y squared, yep. That's first, outer. Outer is y times this -4. Sergio. What's y times -4? I'm doing the outers. Multiply. What is -4 times y? -4y. Keep going. Good job. Next person. I'm going to do, I just did first, then I did outer, then I'm going to do inner. So y times 3. Y times 3. Jenny. 3y. And then I'm going to do last. 3 times -4. Jose. -12. That should, I'm going to copy down the rest of the equation. So equals y squared minus y equals y squared minus y. Oh, I forgot the plus 12, didn't I? Sorry. Plus 12. I have to copy down this plus 12 equals y squared minus y. Give yourself the extra credit point if you found that before me. All right, I need to simplify the left-hand side of this equation, that expression. I have to combine some like terms. Sorry, Wyatt, you've already participated twice. I know. I have to get some more people in here. Yeah, Gunnar. Yeah, and you get
7y negative 1y squared.
or just negative 1y. Yeah, so I have y squared minus y.
And I will do I'll just be 0.
0. And then, oh, okay. So what do you conclude, Gunnar? B is an what is B? It's called an identity. Yeah. I don't know why Khan Academy says it's a true identity. It's either an identity or it isn't an identity. So I just copied the Khan Academy phrasing. But B is an identity. Sometimes the answer is neither. Maybe neither of them are going to be identities. Sometimes both of them will be. But you have to verify by actually multiplying out and reducing, or factoring if you want to do it that way. Somehow get the left-hand side and right-hand side equal to each other, or try. Let's try another one. Example number 2. Which of the following equations are true identities? All right, let's work on A first. And actually, before we even move on too far, let's just eyeball it, right? I have 4a minus 3b, 3b minus 4a. If you remember our trick about factoring out a negative 1 to switch the order of these, maybe you can see it right now. Okay. Now let's actually dive into A. Let's see how we would do the math. Charles, have you only participated once so far? I think you've only gone once. Do you want to do this, or should we let? I don't. Let me do quiet raised hands. Charles is our backup. How do I multiply 4a minus 3b times 3b minus 4a? There's the tricky way of doing it, and then there's the FOIL. FOIL just works every single time. First, outer, inner, last. Jose. Let's do it, yeah. So 4a times 3b. And you said you also want to do 4a times negative 4a. Perfect. And then Charles, let's see if you can follow Jose's work. Jose distributed the 4a into these two terms. Now you need to do what, Charles? Multiply which two terms by what? So where are you getting the, okay. So, okay, sorry, say that one more time. I'm having trouble following you. Yeah? Multiply. Okay, so I wanted you to try to complete Jose's thought process. Jose was, yeah, Jose just needs to multiply the negative 3b by these two terms. And that is what? So plus or minus 12ab. 12ab, oops, 12ab, and there's a fourth term in there. He hasn't done these two yet. B squared, there it is. And I can say we took this term and we multiplied it that direction. Okay, perfect. And I'll go ahead and rewrite the rest of the equation. There's nothing on the left-hand side that I needed to rewrite yet. So I'm just going to recopy equals 16a squared minus 9b squared. All right, I need to reduce the left-hand side. And Jose, Charles, and Wyatt, sorry, you can't talk anymore. You guys have all participated twice. Everyone else is free game though. Andres, go for it.
So you will combine like terms for 12ab, 12ab.
And get?
24ab.
Yep, so 24ab, and then just, what do you want to do from there?
Minus 16a, minus 9b squared.
9b squared.
16a squared minus 9b squared.
Perfect. All right, I'll let someone else make the analysis. What can we do from here, or can we make a conclusion? What's going on? Sorry, what? Sorry, Jose. Okay, get more people in here. You guys have already gone in twice.
And Andres.
Oh yeah, Andres can't do it anymore. That's twice. Sergio's only gone once. Gunner's only gone once. Jenny's only gone once. Jade, have you gone once or twice? Twice. Okay, so Jade's out. Sorry, Andres, you've gone twice as well. Someone make an analysis. What's going on? Sergio, go.
There's an identity.
Say it one more time.
I can. So there's no identity.
There's no identity. Yeah, you're correct. Why? Yeah. Yeah, they're not equal to each other. We've simplified it as much as we can. We can't simplify it anymore. It's only an equation, so it's not A. Cross it out. Everyone cross out A. That is just an equation. It's not an identity. It is true for some values. I don't even want to find what they are. I just know that it's not an identity. Thank you, Sergio. You're in twice. You can't participate anymore. Well, not until everyone else gets in. All right, let's do B. I have this C cubed minus 1 is equal to C minus 1, 1 plus C, 1 or plus C squared. All of that. Let's go ahead and multiply that out. I'll help you guys get the structure up and going. I want to multiply C minus 1 by 1 plus C squared. How do I do that? I'm going to say I have a general rectangle right here. I'm going to make 3 columns because there's 3 terms right here. And I'm going to do 2 rows because there's 2 terms right here. And fill it in. I have 1 plus C squared, and then C minus 1. All right. Question, Andres.
Would you do that table if there were 3 terms in a quantity?
3 terms in a quantity. What do you mean by that?
1 plus C squared. Like there's 3. Like there's 3 things there.
I agree that there are 3 things in there. What's your question?
Like would you do that box if there was a problem like that with 3 variables or numbers in the parentheses?
I mean, you can use this general rectangle whenever you're multiplying anything, even if it's just 3 times x. I can make a box that says, okay, what's x by 3, which is kind of simple. Maybe I can do x plus 1, and I can extend this box over to say plus 1. Anytime that you're multiplying, you can make this general rectangle.
So you can do that like for A too?
Yeah, definitely. We could have done it.
Get the same answer, or?
You get the same answer, yeah. Foiling it is something that you can do in your head, but this is a more, I want to say geographical, and that's not the right word. It's a more spatial way of doing it, so you can see it organized. All right, so I'm going to do rapid fire on people that haven't participated yet. So 1 times C, Cohen. 1C, perfect. Fernando, C times C. Jessica, C squared times C. To the power of what? 3, yep. C to the power of 3. I know these masks make it so I can't hear you guys. And then let's get everyone that hasn't participated twice. So Gunnar, 1 times -1. Close. -1. Cohen, C times -1. Negative C. Fernando, C squared times -1. Negative C squared. Jenny, combine like terms. I'll give you a hint. These 2 are like terms. What's C minus C? 0. What's C squared minus C squared? 0. So those are all canceled out. Shrink, 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 shrink. And when you combine like terms, what do we have left over? Jenny? -1 and C to the power of 3. So that's what happens when we multiply out the right-hand side. The left-hand side is also C to the power of 3 minus 1. So Jessica, what can you conclude by the fact that the left-hand side and right-hand side are exactly the same? It's an identity. Go ahead and circle B. B is an identity. Let's try another. Go to the back. Oh man, there's a mistake.
Teacher.
Yeah.
Teacher.
Who can find it though? Raise your hand if you found it. Only people that find it get it. Don't shout it out if you know it, because otherwise you can give everyone else extra credit. Raise your hand if you can find the mistake. All right, Gunnar, tell us the mistake.
Example 2.
Yeah, it should be example 3. Give yourself the extra credit point if you found that it should have been example 3. Shrink. Should be example 3. Good catch, good catch. All right, so I'm trying to use gender neutral names so you can't tell if it's a boy or a girl. So Taylor was asked whether the following equation is an identity. And it's a much harder problem. Typically, these are harder problems. But luckily for you, Taylor went ahead and solved it for you. So here it is. Apparently, Taylor is going to be using the left-hand side because Taylor is rewriting the left-hand side. And then Taylor goes through the steps. Step 1, step 2, step 3, step 4. It's up to you guys to try to follow Taylor's work. So let's analyze it as a class. Let's see if we can follow what Taylor's doing. So it looks like Taylor is doing something here. How do I get from the original problem to step 1? What did Taylor do? And anyone can participate again because everyone has been in at least twice. I think maybe Gunnar or not. Gunnar, have you been in twice? Yeah. Okay, everyone's in twice. I'll give some more time to think. You guys have to be able to follow these steps. Raise your hand if you think you know how to get to step 1. What did Taylor do in step 1? Andres has a hand up. Who else has their hand up? Charles has his hand up. Jose, Wyatt, Jade. Let's see what Andres. Go for it.
So first he did
Okay.
and then he did x times 3, and then for the second one he did 3 times x, and he added those up, which is 6x.
Okay.
And then he did the same thing. He did he added the 3's. Oh wait, no. He multiplied the 3 into the other 3 in the second term, which was 9. Yeah.
There it is. Okay. There it is. So I don't know. You guys want to give Taylor thumbs up, thumbs down on step 1? I'll give Taylor the thumbs up. Yeah. Good job, Taylor. Step 1. You're good so far. So a simple way of saying what Taylor did to get to step 1, Taylor distributed and combined like terms. He or she distributed the x into the 9x plus 3, distributed the 3 into the x plus 3, combined like terms to get the 6x. Let's see if we can follow Taylor's step to get to step 2. 3x plus 3 quantity squared. How did Taylor do that? And I'm waiting for you guys to raise your hands. How did Taylor get to step 2? Obviously skipping a few steps, but you can get there as well. Waiting for some more people to do some thinking. This thinking is critical time, which is why I give you so much time to do it. What?
I think he factored out the GCF and used advanced.
Okay, so factor out the greatest common factor. What was the greatest common factor?
3.
3. So if he factors out the 3, let's see if we can follow Taylor's work. Help me, Wyatt. So 3 times what's left over, Wyatt?
3x squared plus 2x plus 3.
And then advanced ninja starred. So
Yeah.
3x, 2, and 9. Keep going, Wyatt.
Oh, I don't know. For 2 and 9.
Yeah, me neither. Because the only factors of 9 are 1, 3, and 9. And none of those add up to 2.
Yeah.
So maybe Taylor's doing something else. Or maybe Taylor is doing this method and maybe Taylor made a mistake. I don't know. Could be one of those two things. Let's come back up to here to the formula. That might help us. Yeah, Charles.
They did the first formula up top where there's the square and then there's the 2. So there's the a squared plus 2ab
Okay, yeah, so I guess the way to verify that is take the square root of the first, right? Square root of 9x squared, 3x. Square root of 9 is 3. Multiply these two together and double it, and you should get the middle term. So, yeah. Does that look okay? Do you want to, everyone give Taylor either thumbs up or thumbs down on step 2? Okay, it's actually a thumbs down.
Yeah.
Oh, yeah, 'cause you multiply.
Charles, talk to us.
You multiply those two terms together, so 3x and 3, you multiply those together, it should be 9x as the middle term, or the step 1.
So 9x, and then you double it, you should have gotten 18x, right?
Oh, yeah.
18x, which is the reason that why it got so hung up on advanced InstaStar, because that is a valid method of getting to step 2. It just didn't work. Charles also identified like Taylor used the formula, and Taylor used the formula wrong. In fact, there's no way to get to a step 2. So step 2 is the answer. You would circle step 2. Oh, I guess you'd come down here and say, there's a mistake on step 2. C is the correct answer. Question, Charles.
Wouldn't they also have gotten number 1 wrong?
Step number 1?
Yeah, because if they did number 1 right, they got 9x squared plus 18x plus 9.
If they got 18x, then they could have done step 2 correctly, but they did step 1 correctly. Assuming that you started with this problem, if this was a problem just on Khan Academy, all you can do is distribute and combine like terms. You can't get an 18x by doing that. You can only get a 6x. Eventually, what you would discover is this is not an identity. This is only a formula or an equation. But let's check the future steps. I want to show you a few tricks that Taylor's using right here. Taylor factored out a 3 out of each of these terms, which is what Y was saying. Factor out the GCF. If you factor out the 3, it gets pulled out. It's still being squared though, so you still need the extra parentheses squared. This is a valid operation. To get from step 2 to step 3, step 3 is correct, but I know step 2 there wasn't a mistake. But if you assume that it's correct, which is how I have to think about your test, well, let's assume that there wasn't a mistake on step 2. Did they get the rest of it correct? Should I keep taking away points, or should I just give them, like, is it a 3 out of 4? Is it a 4 out of 4? Like, how many points does that student really deserve? Taylor only made 1 mistake. Step 3 is good so far. Let's check step 4. How do they get from step 3 to step 4? Can someone tell me? Then we'll be done with the notes. Go for a while.
Because 3 was still in the square, he had to square 3, which is 9. So 9 became the coefficient instead of 3 squared.
He squared each of these terms. He squared the 3, 9. Squared the x plus 1 squared, and x plus 1 squared. So step 3 and step 4 are correct. I would have given Taylor a 3 out of 4. He only made, or he or she only made 1 mistake. All right, and that concludes the notes. Correct answer, there is a mistake on step 2. Question, Wyatt?
Can't you go further with 9 times the quantity of x plus 1 squared?
Oh, definitely. But the point was, that was what we were trying to get to. The right-hand side is 9 times the quantity of x plus 1 squared. So once the left-hand side and right-hand side are equal to each other, then you've proven it's an identity. I agree. You could go further. You can expand it out, right?
Yeah, you could square the
Exactly. Yep. Yeah, that's good that you see that. Cool. Well, that concludes the notes. Can everyone give me a quick fist of 5? How well can you use perfect squares and difference of squares, and I guess a few other properties like NinjaStar to verify properties or polynomial identities? Can you say, yeah, that is an identity? I'm getting a 4, 4, 3, 4, 4. Gunner's at a 4, and on Snapchat, 4, 3, 5, 3, 5. All right, thank you.